welcome to our exam prep explainer on facial growth. If you've ever felt a bit lost with terms like displacement, remodeling, and the V principle, you are definitely in the right place. We are going to break down all the core concepts you absolutely need to nail, from the ground level definitions all the way up to how the jaws actually get their shape so you can walk into that exam feeling totally confident.
Okay, let's just dive right in. Here's our game plan. We'll start with the basic vocabulary, get everyone on the same page. Then, we'll look at the scientific methods we use to even study growth in the first place. After that, we'll get into the patterns and timing, how to predict that all-important growth spurt. And then, this is the good stuff. We'll unpack the core principles of bone growth and see them in action. All right, first things first. Before we can really get into the nitty-gritty of how the face grows, we have to agree on what growth even means, right? So let's lock in some of this core vocabulary. This is the foundation for everything else we're about to cover. So what is growth? Well, in the simplest terms, it's just about getting bigger. That's it. It's the increase in size that you can actually measure with a ruler. It's the how much of the equation, a purely quantitative change. Now, growth spurts. We've all heard of them. But in orthodontics, that prepubescent growth spurt, that is our golden opportunity. It's this amazing window of rapid change that we can actually work with to guide jaw growth and fix bite issues way more effectively. Seriously, timing is everything. So here it is, the key distinction you absolutely have to know. Growth is about getting bigger. Development is about getting more complex. Think of it like this. A pile of bricks getting larger, that's growth. But arranging those bricks into a house, that's development. One is about quantity, the other is all about quality and organization. Okay, so we've got our terms down, but have you ever stopped to think, how do we even know all this? Where does this information actually come from? Let's pull back the curtain a little and look at the scientific toolkit researchers use to figure out how we grow. Now, this is a super important distinction. Think of a cross-sectional study as a snapshot. You measure a big group of people of different ages, but you only measure each person one time. In contrast, a longitudinal study is more like a movie. You follow the exact same people over many, many years, measuring them again and again to see the changes. And here are the three classic ways we get that data. Craniometry, that's taking super precise measurements on dry skulls. Great info, but it's always going to be a cross-sectional snapshot. Then you have anthropometry, which is measuring landmarks on living people, so you can do that longitudinally. And finally, cephalometric radiology, which kind of gives us the best of both worlds. We can measure the actual bones on a living person over time. So while measuring tells us that growth happened, these experimental methods show us how it's happening. It's pretty cool. Vital staining literally lights up the parts of the bone that are actively growing in animals. And in humans, the gold standard is implant radiography. By placing these tiny, stable metal pins right into the bone, we create fixed reference points. That lets us track even the tiniest changes with incredible precision. Okay, so we know how we study this stuff. Now let's look at what all that research has told us about the predictable patterns and timing of growth. This is where it starts to get really interesting. You have to know this slide for your exams, Scammons curves. The big takeaway here is that your body doesn't just grow all at once. I mean, just look at that neural curve. Your brain and head size are almost 95% done growing by age 6 or 7. It's why little kids have proportionally big heads, right? And that's so different from the general body curve, which just kind of hangs out until puberty really kicks things into high gear. This idea of different tissues on different schedules is absolutely fundamental. And this graph, this is brilliant. It shows that adolescent growth spurt perfectly. But here's the key. This isn't a distance curve showing total height. No, this is a velocity curve. It's showing the speed of growth. You can clearly see that peak height velocity, the spurt, and you can also see how girls, on average, hit that peak about 2 years before boys do. Planning treatment around this peak is a cornerstone of modern orthodontics. Okay, so this timing is clearly super important. But since it's so different for everyone, how can we possibly predict when a specific patient's growth spurt is going to hit? Just looking at their birthday isn't going to cut it. This is such a simple idea, but it is so critical. A patient's birthday, their chronological age, is actually a pretty poor predictor of their growth spurt. What we really need to look at is their biologic age. Their skeletal maturity tells us exactly where they are on their own personal growth timeline. And that is the info we need to time our treatment perfectly. So how do we figure that out? Well, these are the two main tools we use. A hand wrist X-ray gives us a look at dozens of little bones, and how they're developing gives us a really detailed picture of skeletal age. The other method is called cervical vertebral maturation, or CVM. It analyzes the changing shape of the vertebra in your neck. And CVM is incredibly useful because its stages line up almost perfectly with the peak of that growth velocity curve we just saw. It tells us, hey, you are in the prime window for treatment right now. Okay, this is it. This is the conceptual core of our entire explainer. We're about to break down the fundamental mechanisms that actually drive bone growth. If you can understand these principles, you can understand how the face grows. These two concepts, remodeling and relocation, they are totally inseparable. You can't have one without the other. Imagine a house being slowly moved down a street on a big truck. That movement from point A to point B, that's relocation. But as it's moving, imagine there are workers on it, knocking down some walls and building new ones to change its shape. That's remodeling. The bone moves, and it reshapes itself as it goes. This is probably the best analogy you will ever see for this concept. So the man pulling the cart makes the whole thing move forward. That's displacement. But at the exact same time, you have workers on the cart who are actively changing the wall. They're taking bricks away from one side and adding them to the other. That's remodeling. See? The entire structure moves and changes shape all at once.
Now let's get a little more specific about that movement. When a bone, like your upper jaw, adds new tissue at its connections, at its sutures, it literally pushes itself away from the other bones. That movement, the movement caused by its own growth, is what we call primary displacement.
Now, this next one sounds a little weird at first, but it is such a clever and important idea. For any bone or area that's shaped like a V, growth happens in a very specific way. You add bone or have deposition on the inner surface of the V, and at the same time, you remove bone or have resorption from the outer surface. And this image shows you the result perfectly. You can see how adding bone on the inside, all those plus signs, and taking it away from the outside, the minus signs, causes the entire structure to get bigger and move toward its wide end. This is exactly how many structures, like your lower jaw, grow and expand. All right, let's put it all together now. Let's take these complex principles, displacement, remodeling, the V principle, and see how they actually apply to the real-world growth of the upper jaw, the maxilla. This image really is a perfect summary. That big arrow A shows the overall movement, downward and forward, but it's actually two things happening at once. First, you've got primary displacement, where the maxilla's own growth at the sutures pushes it forward. But it's also being carried along by the growth of the bones it's attached to, like the cranial base. We call that secondary displacement. So it's being pushed and carried at the same time, while that little arrow B shows the constant surface remodeling that's fine-tuning its shape as it goes. And we'll end on a classic exam question that ties this all together. If the face grows in a forward direction, why on earth would bone often be removed from its front surface? And the answer is the core concept of this whole explainer. Facial growth isn't as simple as just slapping new material onto the front. It is a sophisticated, three-dimensional dance between displacement, which carries the whole structure down and forward, and remodeling, which is constantly reshaping all the little details along the way. If you can master that concept, you've mastered the fundamentals of facial growth.